itself. These probabilities in particular are going to be very close to 1. And so again, we have what amounts to a good approximation of, or something very close to a pure, something that satisfies the conditional independence assumption. Here we have a nonsensical example. And we would really want to confirm, if we wanted to confirm perfect conditional independence, we would be looking at all combinations of animal classes together with all these features in the various different slots, and we'd be wanting to compare whether the conditional probability of some set of values was equal to or approximately equal to the corresponding conjunction or factored representation. Here, this probability is going to be 0 or very close to 0. I say very close to 0 because birds don't have hair per se, but we might be taking observations and making judgments about whether they have hair. If we're completely naive about a domain, we might look at a particular bird and look at its feathers and conclude, no, that's hair. Those aren't feathers like I see in an eagle. Those are hair. So I say virtually. This is virtually 0 because it's always possible we have sensors that misinterpret the data and we get maybe small errors. But this is essentially going to be 0. There are no birds that have hair. They have 3-chambered hearts. Some swim, but because of that item right there, very close to 0. And this joint probability is, again, going to be very close, if not identical, to the factored representation, because this term will be 0 or almost 0. That will drive the result to 0. So if we look at the various combinations here, the joint probability equals or approximately equals the factored probability, and under those conditions we can conclude that this is an example where these features add no additional information to other features. The skin cover adds no additional information to the number of heart chambers if you know the class. So these are conditionally independent. These 3 features are conditionally independent given that you know class. Here's another intuitive example of conditional independence. And this is probably less true than the first example. These are languages that are spoken in the world. These are countries of the world. And let's say the class in this case is country. We might look at, it doesn't really matter, but this is what we want to condition on. If we want to know the probability of someone being in the US and speaking English, under the assumption of conditional independence, this would be the probability of someone living in the US, given that we are looking at the world population, and the probability that someone speaks English, an arbitrary person speaks English in the US. So under conditional independence, we're essentially assuming this. If we wanted to compute the joint probability of someone living in the US and speaking English and speaking Mandarin and speaking French, under the conditional independence assumption, we would simply compute this factored probability. The probability of someone living in the US that they speak English, given in the US, the probability that someone speaks Mandarin in the US, and the probability that someone speaks French in the US. It would just be that it would be estimated as that joint probability. This is probably not perfectly true. If you know, for example, someone lives in the US and they speak Esperanto, there is an increased chance that they might also speak French, or they might also speak Swiss, or they might also speak German. Anyone know what, or Yugoslavian actually, is probably the most that would change. Anyone know what Esperanto is? Nobody? Maybe someone online knows. It's a manufactured artificial language. It was intended as the first global language. It was created by linguists to be a global language that everyone would speak. Of the places that it is spoken, I think Yugoslavia is the place it's most spoken. And so this notion of conditional independence is not perfectly true in this case, because if I know someone speaks Esperanto, there might be an increased chance that they speak Yugoslavian, or there might be an increased chance that if they speak Yugoslavian, they also speak Esperanto. And so that would violate the conditional independence assumption, perhaps. So even if I know someone lives in the US, if I additionally know they speak Esperanto, that might have an effect on my probability that they speak Yugoslavian. So in that case, language in some cases does add additional information beyond simply country membership. But those cases are probably relatively rare. And so very often it's the case that we will make an independence assumption, a conditional independence assumption, even if it's not going to be true in all cases. It's going to be good enough. And it's going to pay us a big dividend here. I don't have to remember, if I make this conditional independence assumption, I don't have to go around remembering all possible conditional probabilities or joint probabilities like this. And there's a large number of potential joint probabilities like this. I simply have to remember these individually conditioned probabilities, and that's going to be good enough. So there's a big win that comes with making the independence assumption. But in some cases, it's just a bad idea to make it, because you're going to reduce your potential to learn and perform. So a special case of the